Welcome to Playing with Junk again. Today I want to talk about old Tektronix oscilloscopes. I have 3 of them here on my table. I found them at work in the basement, and the one in the center here is one I bought when I was very young. It was my first oscilloscope. It's the RM504. RM stands for rack mount, and as you can see, it's a 19-inch rack mountable model. There was also the 504 without any letters that had a form factor of more or less like this one, but with the same amount of buttons as this one. And we have the type 453. That's a scope that was made by Tektronix especially for IBM, because IBM wanted to have a scope that their technicians can carry around, and it was in size. A requirement was that it has to fit under an airplane seat. So when their technicians went to customers and had to take the airplane, they wanted to take the scope with them in the cabin, and that's the reason for this form factor here. Then on the other side we have a 7603 mainframe. It's called a mainframe because it's only a base oscilloscope with these modules here. You can change them. Now there is a 7D01 digital logic analyzer, and you could also fit horizontal and vertical amplifiers to make it a normal oscilloscope. There were quite a bunch of modules you could buy for this mainframe to make it suit to your requirements, whatever you needed. I think even spectrum analyzers were available, stuff like that. Unfortunately, the oldest one here, which is dated from 1960, is the only one that is actually working, and it works pretty well. It has a clear, sharp image, scale, illumination, works quite well. The other one here, the 453, worked a couple of minutes ago. Then it went beep and the screen was dark. Maybe we can try it again. Oh, I unplugged it. Let's give it a try. Light goes on. At least that is working. A little bit strange, this trigger lamp here only lights up very dim. That should be bright like this one. But well, I think something has gone here. Trace finder doesn't find any trace. No trace of a trace. Okay, so I better switch that off before it goes up in flames. But I wanted to show you the inside of these scopes anyway, so let's open the covers. Well, and after loosening 18 screws, I removed the bottom and the top cover, and we can have a look inside, and you see it is just beautiful. all the tubes, all the valves, how certain people say, are in one row. They are all labeled with the number of the valve, how it is in the schematic, and also the type. All the transformers are shielded, not only to look nice, but also to well, shield magnetic fields from the tube, which is shielded also with a special shielding metal here. We have the selector switches. And even if the top side is already beautiful, the bottom side is even better. Just look at this. No PCBs, everything is soldered into this ceramic component carriers. The reason why I make this video is there is a YouTube channel called Vintage Tech Museum. Maybe you have already heard of that. They have a lot of original Tektronix videos online, original commercials and education movies of the time. They also have a movie of how to solder these ceramic strips with silver inserts correctly. And something I want to point out is this thing here. That's a small spool of solder wire. It's a special solder wire. It contains about 3% of silver. And there is a note. I hope you can read that. The meaning is that you should use this silver solder because if you use normal thin lead solder without silver, it could eventually dissolve this silver coated grooves here, and the silver could probably fall off, or that's how they explained it in the video. And when the solder itself contains silver, it will not dissolve the silver on these ceramic blocks here, and well, that's the way to go. So they provided you a couple of feet of silver solder here inside the oscilloscope, just in case you have to repair something. But I think this unit now is from 1960. It's more than 50 years old. It was not necessary to repair it since then. And it probably will not be necessary for the next 50 years. I don't know. But it seems to be very stable. The next one is the 453, and I put the cover back on because I want to show you something. It's not just the cover, it also has some spare fuses here, and there is a latch, you can open that, and there is a compartment for your manual, your probes, your whatever small stuff you need. The lines you see here is glue. There has been a foam glued into the bottom and the cover here. I removed that because it was falling apart, and the glue is everything that remained. That's pretty nice, pretty solid. Steel, no, not steel, aluminium. Nice hinges here. Okay, that's the cover. Now the scope itself, it's extremely easy to open. There is one screw on this side. There is another screw on that side. And you only have to loosen it, you don't have to remove it. And you can see there is some sort of notch here on the cover that is held by this screw. And the cover just comes off now. But it doesn't work with one hand, so I'm sorry, I have to use both hands. And we're in. So you see a nice long tube with a quite small display. A lot of boards. I think manufacturing date here is somewhere around 1965, 1967. Oops, show you that the right side up. Yes, mid-1960s, that's the technology here. And I think that's probably one of the first oscilloscopes, not microscopes, with all transistor circuit, except for the picture tube, of course. There were no LCD displays or anything like that around. And that's the bottom cover removed. 2-channel input amplifiers, high voltage box for the tube, I assume. Most of the PCBs are labeled with what they are. I need my glasses. Copyright, blah blah. Type, Tektronix type 453, yes, that's the model. Copyright 1965. Okay, not those. What is remarkable here are these double transistors here. You can see it's 2 transistors in a ceramic housing for thermal coupling, and they are marked NPN and PNP, so you always know which one of the 2 is which. So it's a selected pair of transistors. Here we have the same, 1 PNP, 1 NPN, together in one housing. Very clever design. Input trimmers here, capacitors, trimmer caps. A lot of trimmer. So I think it took quite a while to calibrate this whole machine here properly. Here you can read low voltage regulator. That's the board on the top here. Horizontal amplifier. That's not a silk screen, that is actually etched into the trace here. And what I wanted to show you here on this model, the traces here, they are actually looking like gold, and that has a reason. They are all gold plated. All the PCBs here in this machine, everything is completely gold plated. And the process how they made these PCBs, there's also a nice movie on the Vintage Tech Museum channel. It's called Printed Circuit Boards from Tektronix, and the movie is from 1969, so it's about the era when this model here was built. Later, in the 1970s, they have already given up that process and switched to normal looking tin plated PCBs. And there is the 7603 mainframe, which is also not working. It has a problem with the power supply capacitors. I have to replace them first, but we can have a look inside. So there are two screws that have to be rotated by 90 degree, and then you simply lift it up and unhinge it. Unhinge, is that a word? Maybe yes. Most interesting part of this machine is of course the modules here, because without the modules you cannot use that machine for much. You don't have any inputs or outputs. So that's how it looks inside. I'm not sure, this could probably be the board that makes the digital readout. You have a digital readout on the screen that shows you the voltage and the time base you selected. I think that is that. I'm not sure, it's also possible that the digital readout would be here, because this has the logic analyzer option. It probably doesn't need the digital readout here because it has a digital readout in the module. There is some power supply back here, some horizontal and vertical deflection, and everything else is in the module. And as you can see, there is a little bit something missing. That's the main power supply. There is a huge transformer and some very big capacitors, and I took that out for repair, and well, I will probably make another video when it is running again. And that's the problem of this 7603 mainframe. This capacitor here has become bad. So that's one of the occasions. You probably know if you're working with electronics, and especially if you're repairing things, there are always people asking you, why did it break? Why did it break down? What happened to it? And normally you can say, yeah, well, I don't know. It just broke and that part was faulty and I don't know why. So this is one of the rare occasions where we can actually see how it broke down and probably why. It's a capacitor. It has 14,000 microfarads or 14 millifarads at 25 volts. The capacitor today with the same technical data would be probably like that. Capacitors have become much smaller since the last 30 years. By the way, it was C811. If you happen to have a schematic diagram of this, you would see that it comes from the no, 25 volts. I think it was a 18 volt rail plus minus 18 volt, and this capacitor here had, instead of 14,000 microfarad, just a couple of nanofarads. Now I opened it, of course, already. So let's see what's inside. There is a plastic sleeve around that. And the inside, there's a little bit of foam that holds the core here in place. It smells like old electronics. It smells how old electronics must smell. And the reason, you can see it here, there's one contact. I think that was the minus pole that is still attached to this material here, to this coil of paper and aluminium and whatever goo it has inside. And the other electrode that comes out here and ended here has a large black area here. And if you look closer, I don't know if I can catch that on camera, it looks like a gray paste. So that's the aluminium. Oops, that's too close. The aluminium that has dissolved somehow over the time. You can see the same here. Here that would be where the aluminium band, the same as here on the good side. And that simply broke apart, and of course all the thousands of microfarad disappeared. And the result you have seen before. It makes that weird picture because the ripple suddenly goes into dimensions that is not suitable for an oscilloscope power supply. Well, it simply corroded away, that electrode here, or that connection to the electrode. So theoretically this could be repaired by inserting a new piece of aluminium here, feed it through the cup, but well, it has to be replaced anyway. I will also replace all the other capacitors, even if they look fine when I measured it, but I don't want to screw everything apart again because another capacitor failed. So yeah, I'm waiting for the new capacitors, and then we will see if that was the only problem. The first step was to draw the entire PCB with a pencil. Drawing, erasing, drawing again. That was the task without any computer. After the first drawing, they made it again with masking tape to produce a clean, sharp image of the PCB that is used later for the manufacturing process. This is all handmade, laid out by hand. The masking tape was applied manually. When the manual layout was done, the film got into this reproduction room where photographically it was made smaller to about 1/4 of the size that it actually had. The next step was to drill all the holes. So they drilled the holes before any etching or trace making on the board happened, and you will see why they did that. After the drilling, they put the boards into a chemical bath to deposit a thin layer of copper on the surface, and that was important also inside the holes that have been drilled. And that's how it looks after this first step. A very thin layer of copper has been applied to the entire board and inside the drills, the drill holes. And then they apply the protective film to all the parts that are not traces, because the traces get an additional layer. And that's what it looks like after applying this resist to the board. And then they put it in other baths to apply another layer of copper, a little bit a thicker one. And finally 2 layers of gold, which is shown here. You see the gold plated tracks and the resist on the other parts of the board. And finally they remove this resist cover from the board and put it in an etching solution to etch away all the copper that is not needed. And the gold plating prevents the tracks from being etched away. This is like a protective cover. And that's the result, a clean PCB with gold plated wires and tracks. So that's absolutely perfect and maybe a little bit expensive. So that's the reason why they don't do it anymore. At the last step, a solder mask will be applied, and then the board is ready to go to a flow soldering machine where all the components are soldered from the bottom side. Well, and that's about it. Thanks for watching.